for today's webinar. So today's webinar's topic is an introduction to Kaspersky hybrid cloud security. So we'll see an overview of this particular solution from Kaspersky. An intro about myself. I am Josefa. I am the pre-sales consultant for Kaspersky at Redington Gulf. Okay, so any technical or sales related queries, you can send it out to me, and I will be there to assist you for that. So in today's webinar, we'll have a look at what is hybrid cloud security and different licensing models. And uh, at the end of my presentation, if you have any queries, you can fire your queries in the Q&A section. And also at the end, at the end of the presentation and after the Q&A, we'll have a short quiz, so you can take part in the quiz, and there's a gift voucher for the winner. So I invite all of you to take part in that quiz. We'll guide you how to access the quiz and answer the questions. So guys, in today's presentation, we'll see what is the state of the hybrid cloud nation, or in general, what is a hybrid cloud, and challenges in the times of constant change. So we know that things keep on changing in cloud world, right? So, and in customer environment, there is a constant change. So we'll have a look at that and what are the challenges associated with that. Then we'll have a brief overview of the solution of Kaspersky Hybrid Cloud Security. So basically, it is made up of three major segments. That is Kaspersky Hybrid Cloud Security for public cloud, for data center virtualization, light agent, and agentless technology. And apart from that, we also have VDI, virtual desktop infrastructure security. We have container security, and we'll see in brief the solution architecture and the licensing. So we all know that we are in the era of digital transformation, right? So digital transformation is a constant source of cybersecurity challenges, right? Because if more and more data goes digital, that means it's basically you have more data to protect, right? So along with digital transformation, I always tell that there is also a security transformation that needs to happen, correct? Now digital transformation is here. It's already taking place. So it's not like it's predicted something for the future, something, it's already happening, right? So we are seeing that more and more data is going digital, more and more data is going to the cloud, to private cloud, public cloud. Okay, everything is getting digitalized. So gone are the days where things were maintained in files, hard copies, and all those, right? So everything is going digital. So customers basically move or create new workloads in the cloud. They either move to the cloud, or they create new workloads from scratch. So some of the basic requirements are geographical expansion. Then and one of the major reason for cloud adoption is optimizing the cost. So businesses are in a lot of pressure to optimize their processes and cost, and learning to do more with less. Okay, so it's basically with less resources or with less cost to achieve more. Okay, and basically, when you are migrating from one cloud to another, usually a lift and shift approach does not work. Lift and shift means, if you want to migrate from one physical data center to another physical data center, basically you just take your servers and connect it there, right? But in cloud, it is different, right? So lift and shift might not work. So sometimes you have to build your infrastructure or your applications from scratch in the cloud. Now, some of the risk of hybrid cloud environments is that the risk of downtime or unavailability of applications, Then unauthorized outsider access, that is always a threat with cloud, the security part, uh, you know uh, not giving out unauthorized access to users. And we see a lot of times where the cloud account is hacked, and basically unauthorized application components or compute instances are being deployed. Okay. And there is also a challenge of auto scaling, so we'll see that in the later slide, so how auto scaling is also a security risk. Okay. Then the inability to respond to incidents traversing through cloud apps and data. So the simple thing is, the security solutions deployed with the customer don't have visibility or don't have that particular control on their cloud instances or cloud applications. Now, basically, to minimize this risk, and to what we have to do, we have to, also avoid performance issues, right? In cloud, we are running cloud instances basically to optimize our cost, right? So, if we are using traditional agent-based architectures or heavy duty or heavy agents, okay, utilizing a lot of resources, then the whole purpose is gone, right? So you will be utilizing more resources, and you will be paying up more to the cloud infrastructure or cloud service provider, right? Then compliance is again an issue. Okay, managing compliance is also a big factor or a big risk. Then audit readiness. So as I mentioned, sometimes you don't have visibility into the cloud, and providing security to the cloud, which might be an a violation in terms of audit, that you are not providing sufficient security to your cloud apps and everything. So those are challenges that the IT administrator or the security administrator has to keep in mind. Okay. Now the solution to all of the challenges that we saw is Kaspersky's hybrid cloud security. And it's basically a solution that covers a broad attack surface. It covers different sets of infrastructure. Okay. Now, you might be in touch with a lot of customers. Okay. And you are aware that not all customers are on a single cloud. Okay. Or not all customers have all of their services on premise, or all of their services on the cloud. It's a hybrid environment, right? Okay. So we have seen that most of the customers have a combination of either on premise, okay, hardware servers and workstations, then hosted servers, then virtualized server infrastructure like VDIs. Okay, then they have containers. Some of the services are hosted on public cloud, and not just one public cloud. The customer might be using different public clouds, uh, you know uh, depending on their developers request. Some might be comfortable with Azure, some might be comfortable with AWS, right? So it all depends on developers as well, applications as well. So a customer might have services running on multiple clouds, be it private cloud, or be it multiple public clouds, right? And and it might also happen that they shift between the clouds, right? Okay, sometimes their services are on certain cloud, they might want to bring it on prem at some later stage. So you should have a solution which caters to sort of this dynamic architecture or this dynamic nature of cloud, right? So Kaspersky's solution is Kaspersky Hybrid Cloud Security. Now, we'll see the evolution of this particular product. So back in 2012, okay, Kaspersky launched the Kaspersky Security for Virtualization. In 2014, they released the Light Agent technology, which is their patented technology. So no one else has this particular technology. Then they also introduced Light Agent for Linux. New platforms and virtualization technology started getting supported. Okay, and in 2018 they introduced the Kaspersky Hybrid Cloud Security. Okay, which is basically a combination of multiple solutions. So we'll see in the later slides. Okay, so as I mentioned, Kaspersky hybrid cloud security is a consolidation of, or a bundle of various Kaspersky solutions. Okay, so it's one solution made up of made up of a bundle of other technologies. So we have Kaspersky Security Center, okay, which is our single pane of glass management solution. Then we have Kaspersky Security for virtualization, for light agent, for agentless. Okay. Then we have KSWS, that is Kaspersky Security for Windows Server. Then we have Kaspersky Security for Linux. Then we also have Kaspersky Security for cloud. Okay, for public clouds. So basically, it's a solution that is designed for virtualized environment for server OS. Okay, it's a solution designed for your data center, whether your data center is on private cloud or whether public cloud. So it is designed to cater to virtualized environment. So it also supports physical servers. So it's not like it will only support virtualized servers. No, it's a one-stop solution for all your data center requirements. Okay, so it also has KSWS. So you can that is Kaspersky Security for Windows Server. So basically you can use KSWS to deploy it on physical servers as well. Okay, so now we'll have a look at Kaspersky's solution for public cloud workload security. Now we know that even with proper cloud deployment configuration, risks are still high for unsecured workloads. Okay, so this is basically because of the shared responsibility model. Okay, we'll have a look in the next slide. Okay, next few slides we'll see the shared responsibility model, what exactly it is. So, and even if some of the responsibilities or some of the security is done by the cloud service provider, still you are responsible, or the customer is responsible for protecting the data, for protecting the workloads, right? Okay, so you just cannot rely on native cloud security. So because and how do you connect to your cloud workloads? Either through SSH if it's Linux, or either through RDP if it's Windows, right? So for these cloud workloads, there is a constant threat of brute force attacks on RDP and SSH ports. Okay, so simply spinning up a VM and enabling the public IP for RDP and SSH, you might be under the threat of a brute force attack. So your credentials can be compromised, and you have exposed services at the network and OS level vulnerability. So as I mentioned, once you deploy a VM, once you deploy an instance in the cloud, you as a customer are responsible for protecting that OS, for protecting your subnet, for protecting your security group or whatever. Okay, so supply chain attacks, example repository poisoning. Then there are network-based attacks, example DNS hijacking, and then there is denial of service. So some service providers have some basic denial of service protections as well. So from endpoint level of attacks or OS level of attacks, there is nothing that the cloud service provider can do. It is you as a customer who is responsible for this. So examples of some of the attacks on cloud workloads are, malicious Node.js modules. So some of the modules, Node.js, it's a module which can be deployed, okay, or which can be installed on your workload. So if you use some malicious ones, your systems can be infected with that. So multiple vulnerabilities, if you don't keep your OS and your applications up to date, you are exposing your vulnerabilities. Then we already saw the SSH and RDP brute force attacks. Then there is protocol based attacks like Eternal Blue. Okay, then there is Linux distributive poisoning. Then there is container attacks, that is infected Docker Hub containers. Okay, so So when we are talking about cloud workloads, we are basically also getting introduced to a host of different types of attacks. Okay, so it might happen that some physical or on-prem attacks are not relevant to the cloud, but cloud is a different scenario, right? So it also comes with its different sets of threats and attacks, right? So we also have to be prepared to cater to these type of attacks. Now this is the shared responsibility model that we talked about. Okay, so uh, so in the shared responsibility model, okay, so for example AWS or Azure, so they are responsible for basically the compute, the network, the storage, okay, and all in securing the compute, securing the storage, securing their networking. So they are responsible for that. They are also responsible for securing their hardware, their physical connectivities, their data centers for disaster recovery, their availability zones and all those, okay, for failures, for for load balancing, for fault tolerance. So they are responsible for that. But as a customer, you are responsible for the data that will be held in those cloud workloads or cloud instances. You will be responsible for controlling access to those responsibilities, that is identity and access management. You will be responsible for the applications you deploy on those instances, okay. And you will be also responsible for the OS that is running on those instances. So you are the one responsible for updating or patching the OS for the applications and securing the securing your data, okay, or securing customer data. But rest all is taken care by the cloud service provider, okay. But data is something that you are responsible. So and it can only be secured with cloud based or cloud native security, okay. So we'll have a look at our solution as well. Now now with the responsibility of networking gone or compute gone or storage gone, so we are less responsible for that, right, as a customer on the cloud workload. But with that responsibility gone, we are also losing a lot of visibility, right? So there is always an old way of doing things. You can do a VPN stitch, to get a hold of infrastructure, and you can just connect your on-premise architecture to the cloud architecture via VPN and handle the cloud workloads as just as same as your on-premise workloads, installing the same agent that you do on your endpoints or servers. But is that the best way to do it? Okay, are you basically justifying the security or justifying the movement to cloud with just extending the security from on-prem to cloud in a traditional way, okay. And sometimes you with your existing solution you might not have that option, right? So you basically are going to do it, but that is not what the customer wants, right? Okay, so um, basically uh, if you go with the older approach of VPN and extending your on-premise endpoint security solution to the cloud, basically you are not taking advantage of the cloud architecture, and you are leaving behind a lot of benefits. So potential impact, now we will see the impact of not incorporating or not deploying a proper set of security. So a data breach, when a data breach happens, it's directly proportional to cost, okay. So when a data breach happens, so your cost also add up, and your cloud workloads can be a stepping stone for cyber criminals, okay. They can also take over the cloud console, your cloud account, okay. They can also do cloud resource hijacking, including infinite computing scale up, okay. Example, cryptocurrency mining. I'm not so sure whether all of you are aware of cryptocurrency mining, okay, or it's also called as crypto jacking. So basically what happens is they might infect they might infect your system, Okay, and this happens on cloud a lot. Okay, that means they might infect your system and use your system's resources for mining cryptocurrency for them, for the attackers. Okay, so the cloud providers have auto scaling groups. So when the resources of a particular instance goes high, it can auto scale. It can either scale up or scale horizontally. Okay, that is deploying more and more instances. Okay, so basically the attacker can take advantage of that. Okay, and basically if more and more instances are being deployed, that means the attacker can use more and more resources. So if that is not stopped, you will be paying a lot of bills for the attacker's benefit. Okay, so the attacker gets the benefit of using up your resources for mining or cryptojacking for his benefit. Okay, so reduce so basically with Kaspersky's hybrid cloud security, you are reducing the exposure to threats with consistent visibility and control, radical attack surface reduction, automated provisioning, rich and flexible reporting, and also next gen threat prevention. Okay, so all of these solutions are incorporated into hybrid cloud security, so you are greatly reducing the attack surface with and gaining more and more visibility into your virtualized environment, be it on-prem or cloud. So consistent visibility and control. So we have a very tight integration with AWS and Azure's native APIs. Okay, we have a single management console for both public cloud and your virtualized on-premise infrastructure and the physical servers as well. Okay, so as we mentioned, we have native multi-cloud operation as well. You can spin up, the resources from AWS cloud or Azure cloud. You can, deploy the hybrid cloud security in the cloud as well. Okay, or you can deploy it on-prem and extend it to the cloud. Okay, so or some customers even prefer to keep the console separate for on-premise architecture and for cloud architecture, so we also support that. So basically you can have the hybrid cloud management separate for cloud, you can have hybrid cloud security management separate for on-premise, or you can have single instance which manages both. Okay, so it's a very flexible architecture, so customer is free to use whatever architecture he wants. We also have automated rollout. So basically we have integration with cloud APIs, okay, which provide automation and administrative flexibility. So the management console uh, should be able to see all the instances running under the specified accounts of cloud. Okay, and use that information to deploy security agents. Okay, so we should have visibility into the accounts of the instances, and once we have that visibility, we'll be able to deploy those agents automatically. Okay, and as well as we can apply some predefined security policies specifically designed for cloud architecture. Okay, so also when a new instance is created on the cloud, we can use an identity and access management role on the cloud or a script to automatically deploy and protect that particular new instance. Okay, and for AWS, okay, we also have cloud formation templates. So if you're aware of cloud formation templates, so you can go to Azure Marketplace and basically deploy hybrid cloud security using their predefined cloud formation template. So it's basically very fast to deploy. Within an hour you can make your hybrid cloud security up and running. So as I mentioned, we have two models on cloud. We have pay as you go, as well as we have or we have pay as you go or pay per use, and we have bring your own license. So So a pay-per-use basically enables security procurement and billing directly through the cloud providers marketplace. Okay, so it's available for AWS currently, and BYOL is available for both AWS and Azure. So BYOL is, you can activate a license obtained from a Kaspersky partner. So partners like you, okay, the customer can contact you and ask for a license, to be purchased from you and directly from us as distributors. Okay, so pay per use means, the customer directly has is paying to us, to Amazon and to Kaspersky, not to you as a partner. So always push for BYOL as a partner. Now, this was all about cloud security. Now we'll have a look at data center security. That means I'm talking about on-prem data center. So, when we talk about on-prem data center, so why traditional agent-based security is not efficient is because sometimes there is a requirement, compliance requirement, or some risk management requirement that there should be an agent deployed. So in such scenarios, if you use the traditional agent based security, so what happens is every agent puts some stress either on storage, okay, or the network. Every agent updates and scans whenever they deem appropriate, okay, usually at the same time, for example 9 a.m. or 1 p.m. lunch time or something, okay, and it can basically generate scan and update storms. Okay, so if all your virtualized devices are scanning or updating at the same time, it can generate a scan and update storm. Okay, and every agent is on its own. Okay, so you don't know basically whether it is updated or not. Okay, or because each agent is on its own, and each agent is deployed on a separate endpoint, and each endpoint may act differently. Okay, due to some reasons or some policies, an agent on a particular endpoint is not updating. Okay, so you don't have proper control. So basically you are opening up a window for a vulnerability. And so the whole problem is that, okay, agents do not leverage the work, okay, of other agents. Okay, all agents work independently. Okay, so if something is caught by a neighbor system, a neighbor agent, that is not shared to all the other agents, right? So every time for each of the agents on each of the endpoints, they do all the things over and over again, okay, resulting in a waste of resources, lower consolidation ratio, and basically diminishing the virtualization ROI, or return of investment, right? So centralization security for efficient VM protection. So centralizing your security is a must for efficient VM or virtualized environment protection. So what it does, it eliminates redundant data and operations. So you don't need to scan things over and over again. If something is found out by one particular endpoint, it can be shared across. Okay, and because of this centralization security, we'll see what is centralization security, what does it mean, and how we do it with our light agent and agentless technology. So we'll see that shortly. But what it does basically, it will help in dramatically reducing the IOPS cost, the IOPS count. It will dramatically reduce the CPU cycles, the memory footprint, the CPU footprint. Okay, and on an average, it basically uses up to 30% less of virtualization resources than a traditional agent-based architecture. Okay, result is more VMs on the same hardware. Okay, so on the same host, you can deploy more VMs because you are now utilizing less resources for your other VMs. Okay, because either it is agentless or agent. So you're not utilizing heavy agents, which which needs heavy resources, high memory, high CPU, right? So basically you can run lightweight VMs, so that will allow the customer to run more VMs on the same hypervisor or same host. Okay, the resources can also be reallocated to reliability resource pools. So we have two technologies for virtualization or data center virtualization technology. We have light agent and we have agentless. Okay, so light agent supports all most popular hypervisors. Okay, lightweight agent adds critical security capabilities while keeping high VM density, means more VMs on the same host. Okay, it offers web device and application protection and policy enforcement. It also provides exploit prevention. It blocks exploitation of vulnerabilities and privilege escalation. We also have agentless technology. So agentless technology is very, very tightly integrated with VMware's NSX, vSphere, and vShield endpoint. Okay, there is no duplication, so preserving consolidation ratios and high VM density. Easy to administrator and deploy for instant protection and security. Since it is agentless, the deployment is instant, it is very quick, so there is no need for any agents to be deployed. But uh, but the thing is, it only is available as of now for VMware. Now, light agent patented architecture. So we have our light agent architecture, which is patented. So we have our management console, the Kaspersky Security Center, and we have an integration server, VIIS. Okay, basically, this is the server which integrates with the virtualization platform, and we have our management console, which basically is our single pane of glass management for all the policies, for events, for tasks, for deployment of agents. Okay, for a light agent as well. And we have uh, a VM running on the host machines, okay, or hypervisors called SVM, that is security virtual machine. Okay, basically this is the technology which offloads all of the processing, all of the resource intensive task from the endpoints or from the VMs. Okay, so that is why the VMs utilize very less resources on their own, because all of the resource intensive task is offloaded to the SVM, and SVM also maintains a stored cache. So when there is some result or some outcome from some file verification or file scanning, it stores that. So if something else comes, it does not have to do it again and again, so it can use the same result to tell the other endpoints, okay, this is malicious, this file was malicious, I don't need to scan it again because I already have scanned it from other systems. So there is no redoing of similar task again and again. Now you can also have SVM deployed on other hosts to have load balancing, to have failover. Okay, so light agents can communicate to SVMs, to multiple SVMs as well, so to give failover and load balancing. So this particular architecture is a patented architecture from Kaspersky. And basically, this is in brief about what we discussed. So there is security virtual machine. It's a special purpose VM. It provides file level threat assessment service to the VMs. It optimizes performance for eliminating redundant data, that is keeps central definition database. So you don't need to update each and every agent. So the database of signatures or whatever intelligence, it does not have to sit on each and every endpoints. It just sits on the security virtual machine. So it reduces your storage usage. Okay, and with all the file level threat assessment being done on the security virtual machine, it greatly reduces your processing and RAM utilization as well. Okay, it balances the load between multiple hypervisors. So if you have more number of VMs, Okay, you can also deploy more SVMs. So typically, you can have, uh, um, if you use the default SVM resources, okay, you can connect up to 50 to 70 light agents. Okay, but if you want to connect more light agents, you can basically increase the resources of the SVM, or you can deploy multiple SVMs to load balance. If you want the proper formula or proper guide of number of light agents with SVM, you can find it in the administration guide, how to calculate the resources and how to calculate the number of SVM. So it is there mentioned in the administration guide of light agent for hybrid cloud security. Then we also talked about the integration server, the VIIS, that is virtual infrastructure integration server. This is the server which provides the tight integration between Kaspersky and the virtualization technology. So solution highlights for light agent. So it's a patented technology. Okay, it provides system hardening, exploit prevention. Okay, it provides protection from ransomware, for not just for operating systems. It also provides ransomware protection for shared data, shared folders. Okay, it also has efficient network security. It provides firewall, deep traffic inspection, packet analysis, IDS, and network attack blocker. Okay, it also provides single pane of glass management through Kaspersky Security Center. We have native API integrations with a variety of on-premise virtualization technology like VMware NSX, Microsoft Hyper-V, Citrix Hypervisor, KVM Hypervisor, Proxmox, and Huawei Fusion Sphere. It basically supports most of your virtualization technology. So you will hardly find anything which is not mentioned here. So we also discussed that light agent is much faster in terms of performance when compared to traditional antivirus. So as per internal tests conducted, so it was found that it is 3 times more efficient in terms of processing, uh, twice efficient in terms of RAM usage, and 5 times more efficient in terms of storage usage, or reducing the IOPS. So basically a consolidation, a table view of what we discussed in the previous slide. So hypervisor resource utilization, okay, so plus 5% we offered, plus so only 5% more resource utilization of the hypervisor compared to 25% from traditional antivirus. CPU usage only 1 to 5%. Okay, traditional antivirus 10 to 15% more CPU usage. The biggest difference is in CPU queue length. Okay, that is 20% to 150%. And memory usage was up from for only 5 to 10% on the workloads, whereas in traditional antivirus it goes up to 25%. Hard disk queue length 3 times, whereas compared to traditional antivirus, which is 7 times. Okay, file operations 5 times, and this is 8 times. So another alternative to our light agent technology, where an agent is installed, but it's a light agent. It's just offloads the processing to our SVM, that is security virtual machine. Okay, but still there is an agent installed, but that agent usually does not do the resource intensive processing. That's why it is called a light agent. We also have a completely agentless technology. Okay, so it's hybrid cloud security agentless, and it is only available for VMware. Okay, so basically uh, our agentless approach leverages VMware vShield driver to provide protection of Kaspersky security for virtualization. Okay, so it offers file level protection, it offers network level protection, instant VM protection without deployment of an agent. It provides native API integration with VMware, offline scanning, okay, and it also has automated SVM deployment to new hosts. So, so we'll see. Okay, Kaspersky security for virtualization. Okay, so as we saw in the light agent as well. Okay, so there is no storm for updates or for scans. So it has native VMware hypervisor. It is native for VMware hypervisor. It has permanent protection for all VMs. Okay, it has efficient use of resources because it is agentless and keeps VM density high. So you can basically run VMs with lesser resources, maybe 1 vCPU, 2 GB RAM, 2 vCPU, 2 GB RAM. So you can basically run smaller VMs for your usage instead of just adding more resources just to run your traditional antivirus. You can run comparatively smaller VM so you can have more VM density. The con is that it is only file level anti malware. Okay, so but we can uh, work. So I'll show it in the next slide. So here it is. We'll come to that slide. So we if I go back to our original, so only file level anti malware, okay, which is done by the SVM. Okay, whereas light agent does all of the things without requiring any additional VM called NAB, network attack blocker. Okay, so but major IDS functionalities, IPS functionalities, and all those can be achieved. Okay, which are not file based attacks. It can also be achieved in agentless through the addition of another VM called as network attack blocker. And so basically this the first con, which is only file level anti malware, can be taken care of, and the other con is it is only for VMware. So that's it, no other potential security compromises or security gaps. So it has everything when we talk about integration with SVM and NAB. So this is what we discussed. So it has inbuilt integration with VMware NSX. So the NSX is responsible for the distributed firewall, virtual LAN, virtual networks, VPN, secure activity monitoring, and the Kaspersky security for virtualization. Agentless is responsible for anti-malware, security policies, integration, automation. Okay, virtual network, IDS and IPS, security tags integration, multi-layered security. So again, it's not just a traditional or a file-based or a signature-based antivirus. It is a next gen antivirus. It has multi-layered security. So this is a reference architecture. So on the left hand side you have the NSX components. On the right hand side you have the VMs uh, 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 with installed VMware tools and NSX file introspection driver. And you also have the SVM and NAB from Kaspersky. So SVM is security virtual machine and NAB is network attack blocker. So I think we can a little bit short on time, so we'll just skip through some slides. Okay, so I just quickly wanted to show you or talk about the VDI architecture, virtual desktop infrastructure. Okay, so our Kaspersky hybrid security saves up to 30% of virtualization hardware resources compared to using a traditional endpoint security solution. So after learning the environment, the solution can often instantly produce a verdict. Okay, so it monitors, it observes, and it can instantly produce a verdict without spending a single extra cycle. So rich and flexible systems hardening functionality. It has a rich and flexible systems hardening functionality, which basically reduces the attack surface, it prevents arbitrary code execution on servers, and it blocks exploits. So all of this with basically no noticeable increase in resource consumption. So virtual desktop infrastructure, also known as thin clients, you already know that, right? So it's basically very less in terms of resources, right? So it helps in greatly reducing the resources with our Kaspersky hybrid cloud security for VDI. We also have container security. Okay, so container security is or basically in general, container as a technology is one of the most important use cases for public cloud. Okay, so basically containers are used on public clouds by the DevOps, or by the administrators or software developers. So but the adoption and wide use of container technologies, okay, such as Docker, creates a persistent challenge for security managers. Okay, so Kaspersky hybrid cloud security can help you secure your Docker environment and Windows containers to prevent an attacker from using a malicious container component as a stepping stone into the organization's internal. So you can see it on the right hand side. So so anything that is malicious can be restricted inside the container. Okay, so containerization, host memory protection, task for container and image scanning, and scriptable uh, interfaces all enable security as code approach. Okay, with the ability to integrate security tasks into CI and CD pipelines. So to summarize, Kaspersky hybrid cloud security is security for any cloud, that is public cloud, virtual data centers, and physical data centers as well. Okay, so well, for public clouds, we have integration with native APIs. Okay, you can deploy it even from marketplace. You have BYOL and pay as you go approach. Okay, for software defined data centers, we have our agentless and uh, a light agent technology. We have patented security technologies for VDI, for containers. Okay, and also for physical data centers, we have security, Kaspersky security for Linux. We have Kaspersky security for Windows servers. So basically, it is security for any cloud. So if you want to summarize or explain anyone what is hybrid cloud security in a single sentence, it is security for any cloud. Okay, so here we have borderless cybersecurity orchestration with role-based access management, unified security orchestration, centralized monitoring and reporting, cloud API integration. Then we have system hardening features like application control, okay, default deny, that is all applications are blocked until and unless allowed. We have device control, network segmentation, firewall management, and we have our generation API, next generation antivirus with artificial intelligence and machine learning. So we have various technologies like log inspection, cloud assisted intelligence, anti malware, app privilege control, HIPS, host intrusion prevention and host intrusion detection. We have file integrity monitoring, anti ransomware, exploit prevention, behavior analytics. We have anti crypto, we have remediation engine. Okay, so basically anti ransomware, anti crypto, remediation engine, whenever if there is an attack, okay, and for some reason uh, the attack happens and the files are encrypted, we can roll back those files. Okay, so we can roll back a ransomware attack. Okay, so we have anti ransomware protection which protects against ransomware attacks, but as we all know that security is not 100%, right? So there is a 0.1% chance that some attacks might go through. So we have a remediation engine. So if that attack goes through, we are also able to roll back. So we also have post attack mechanisms as well. So we already discussed this. So, and this is a very good slide. Okay, so in 2019, Kaspersky products participated in 86 independent tests and reviews. In out of those 86, in 64 of the tests, Kaspersky was rated the number one solution. Okay, so it was in the first place for 64 tests. Okay, and for more and for for 70% of the tests, it achieved in top 3 ranking. Okay, now licensing, it's very quickly in one slide we'll just end it. So just keep in mind, so there are a few questions for this. Okay, so we have two basically additions for Kaspersky hybrid cloud security, that is Kaspersky hybrid cloud security standard and Kaspersky hybrid cloud security enterprise. Okay, so enterprise has all the features, so some of the features that enterprise has, that standard does not have, that is application control for server, file integrity monitoring, log inspection, next generation IDS IPS, and large scale environment support. Now KHCS is licensed per workload, okay, or per VM, or for for private cloud it can also be per CPU. Okay, so either it can be per workload or it can be per CPU. So per workload, usually it's a standard one for on-prem or for cloud, but for cloud you always go with the per workload because you don't have control over the CPU, with auto scaling and all those. So it's better to use per workload for as a standard. But if you have a private architecture and you know the CPU count and everything, so it's also good to go with the per CPU approach. So two license additions, that is standard and enterprise, two licensing modes, that is per workload and per CPU. So guys, that's it from my end. I hope this session was helpful in giving you a brief about Kaspersky hybrid cloud security. So we'll quickly see if there are any questions, and